Good morning, my dear students. This is again your Virat Kumar, lecturer in Electrical and Electronics Engineering from the Institute of Government Polytechnic, Vaddepalli. And as usually from the fourth semester with the subject of AC machines with the code of 18EE403C. And today I am here to explain you about the welding transformer in the major topic of three-phase transformers. Welding transformer. In the general view, what is a welding? In our most common life, we may be met at least one times with a welding, but we may have seen them in order to join the two metals. In each and every, for domestic use or industrial use, we may be seeing it at least once in our life. So today we'll be learning about what is a welding transformer, what does it do, how it's made, application, things, and we'll see a small recap. Let us recollect what we have learned in the last session. Transformer, working principle, and auto transformers. We have seen auto transformers. And in the auto transformers, you have learned how to save the copper and how the construction is and what are the technical aspects in it, and all those things. And today's objective is, on completion of this period, you would be able to understand about the welding transformer, current control methods, tapped reactor method, moving coil method, and saturable reactor method. So these are the things which we are going to see in this session. The things are welding transformer, current control methods, tapped reactor method, and moving coil method, and saturable reactor method. Yes, please make a note of these topics so that we'll step into them one by one. Okay, now moving on to the next slide. The AC power sources for welding. AC power sources for welding. There are mainly AC generators and AC transformer. These are the two main things for AC power sources for welding. One is AC generators and the other is AC transformers. As you all know what is a generator and what is a transformer. Moving on to the next slide. Firstly, we'll see AC generators. As you all know, you may be learned in the third sem about DC generators. In the same principle, we'll be having AC generators also. So these are also called as alternators and driven by AC motor or a diesel engine. A frequency can be controlled by speed of rotation. And you can see the animated picture over here. So this is the North Pole. This is the North Pole and this is the South Pole, and there is a conductor rotating in between these two poles, and it is cutting the magnetic field from north. There will be a magnetic field from north to south. So it is cutting the magnetic field. So according to Faraday's law, whenever a conductor is placed in between the magnetic fields, and when it tries to cut the magnetic field, an EMF is induced in that conductor. So that is why you can see the EMF is induced. And whereas these two are the slip rings, where we can collect the supply from the rotating elements. Since it is rotating, so we cannot directly take the supply so that the wire gets wound. So that's why there are two slip rings to phase neutral or plus and minus. So this AC generators is also called as alternators, and that since it is rotating, that can be driven by AC motor or a diesel engine. And whereas this frequency can be controlled by speed of the rotation. You may know the formula for frequency. F is equals to NP by 120. NP by 1 second. P by 120. With any speed, P is number of poles and 120 is constant. So if once the poles are fixed, cannot be changed. 120 is constant, so the speed can be changed. So by the speed is increasing, then the frequency increases. If the speed reduced, then the frequency also gets reduced. So by that, the frequency can be controlled by speed of the rotation. Is directly proportional to n. You can write over here F is directly proportional to n, where n is speed. And moving on to the next slide. AC transformer or a welding transformer. We'll be seeing it. You can see a practical picture over here, which is a welding transformer. It changes high voltage and low ampere range power to low voltage and high ampere range welding power, and works on principle of electromagnetic induction, least expensive, lightest and portable. So these are some special features of the welding transformer, where you can see that it changes high voltage low ampere power to low voltage high ampere welding power. Actually for welding especially, it requires, you maybe know that whenever two rods is to be joined, the thing is that two elements at that surface wherever the joint is required should be get melted and then cools down with naturally or forced, and the metals gets attracted. That means it can be joined, the joint may be formed. So in order to melt that material, we require heat. Actually that heat can be, you know the formula for heat, that is I square R. Mainly for welding we require heat in order to melt the metals, and we know that heat is equals to I square R T. Just to time that. So for heat, mainly the current should be more the current, square times of it gets more the current. So that is why see here welding transformer, it changes high voltage low ampere range power to low voltage and high ampere range welding power. Since we require high ampere, ampere means current, high ampere, so This welding transformer changes high voltage low ampere range power to low voltage high ampere range welding power. That's the thing. By this high ampere is obtained, by that we can produce huge heat and we can melt the metals and make a joint. And it works on the principle of electromagnetic induction. As we all know, transformer works on the principle of electromagnetic induction. And it is very least expensive. We just require a transformer, that's it. And lightest in weight, and it is portable, can be moved from one place to another very easily. Yes, please make a note of them. Okay, moving on to the next slide. Parts of a welding transformer. The main parts of a welding transformer are the frame structure and a cooling system. This is since the inside this is a core or a frame structure. Inside it we have a transformer with immersed oil and all those things. It's like a general transformer. The frame structure and the cooling systems. The cooling system is very essential because it produces huge heat. By that, the machine may damage. So, in order to avoid that, a cooling system is required to cool down the device from the damages. Just substitute the diagram. Okay. In general, there is a transformer with core, with primary winding and secondary winding. So this is the primary winding. It's a core, and this is the secondary winding. It's current control mechanism. If there are more number of turns present in the secondary, then we can build up the more voltage, and less number of turns, less voltage and high current, and more number of turns induces high voltage and low current. So that is why it is called as a current control mechanism. This is the primary winding with NP number of turns, primary current IP, the primary voltage VP. There is a magnetic flux continuously revolving through the path of the core. And this is the secondary winding with NS turns and the secondary current of IS and secondary voltage of VS. You can see there are more number of turns in the primary and less number of turns in the secondary. That means you have more voltage in the primary and less voltage in the secondary, and less current in the primary and high currents in the secondary. The thing is, whatever the number of turns, but there is no change in power from primary to the secondary. Yes, voltage and currents may differ, but there is no change in power and as well as frequency. We will be doing the transformer is a static device which is used to convert the levels of voltages from one to the other, from one circuit to the other circuit without any change in power and frequency. We will be doing it all. That's the main concept. Now, welding transformer. Cooling is done by oil or by air. As I've said you, if it is done naturally, that is by air. If it is forced, then but is by oil. Core is made up of silicon steel or CRG. Primary winding is connected to power source. As we all know, the primary is connected to the power source. It acts as an input to the welding transformer. Secondary winding is connected to load wherever the welding job is done. And drooping characteristics can be obtained by means of reactance coil. Please make note of all these points. Cooling is done by oil or by air. The core is made of silicon steel presently, which is used by CRGO, cold rolled grain oriented. The primary winding is connected to power supply. The secondary one is connected to load wherever the job is done, and the drooping characteristics can be obtained by means of reactance coil. Okay, moving on to the next slide. Here there is a picture of the welding transformer. You can see here, this is the primary side with more number of turns, and this is the secondary side with less number of turns. The primary is connected to the supply, AC supply, and the secondary side has the tapped voltage. That means 100 volts, 80 volts. There is tapping with a reactive coil, and you can connect either to 80 volts or 100 volts. There is a tapping. It depends on the requirement. That is directly given to the material with it to be joined, and from the reactive coil, the reactive coil is used to control the current, and from that there is an electrode holder and electrode where the joint has to be done. That electrode has to be placed on that. You can see here, secondary voltage of transformer is almost constant. When arc is struck, the voltage drops across reactance coil. A reactance coil controls the welding current, as I said you. Please make the diagram and make a note of the points. Secondary voltage of transformer is almost constant. Either you may be connected to 80 or 100. And when arc is struck, the voltage drops across reactance coil, this reactance coil. And the reactance coil controls the welding current. Okay, moving on to the next slide. Regulating the welding current. As I said you previously, we can control the welding current by a reactive coil, so that regulating the welding current can be done by tapping reactor method or moving coil method, saturable reactor method. These are the three methods where welding current can be regulated. One is tapping reactor method, moving coil method, and saturable reactor method. Let us step into the each method. Firstly, tap reactor method. The diagram is very simple as in the previous welding transformer. Same primary and secondary, where a tapped reactor is there over here with multiple number of tappings. We can change this tapping. By that we can control the welding. Correct. This is the material where the job has to be done. That is given that to the metal, and this is the electrode holder with an electrode is connected to the tapped reactor. Just make the diagram. Okay, moving on to the next slide. In this tapped reactor method, you can see the output current is regulated by taps on the reactor, and the limited number of current settings is possible. These are the two main points to be noted, that the output current is regulated by taps on the reactor. There are 3 tappings over here, you can see clearly. And the another main thing is there are limited number of current settings is possible. Okay, moving on to the next slide. This is a moving coil method. This is a second method where it is called as the moving coil method. What is moving coil method? Actually, moving coil is observed in the energy meters, and we'll see what is the thing in it. See, there is a handle over here. There is a coil, moving coil type structure, and this is the primary and this is the secondary. And primary is connected to the AC supply, and from the secondary it is directly to the holder, and then to the rod, electrode holder, and this is the electrode where the work has to be done, and this is the arc. Just make the diagram. Okay, Then we'll see some main topics in it. So the distance between primary and secondary windings can be changed. See, the primary is over here and secondary is over here. And the distance between the primary and secondary can be observed over here. That can be changed. And more the distance, less in the current. If there is a lots of distance between them, then the current is very less. And coil can be moved with moving arrangement. So these two, this is the primary coil and this is the secondary coil, and that coil can be moved with a special moving arrangement. That is why it is called as a moving coil method. So the main thing is more the distance, less in the current. The primary and secondary distance, if it is more, then the current is less. In order to increase the current, the distance has to be reduced. That means secondary has to be brought very near to the primary, and that can be made or moved with a special arrangement, that is moving arrangement. Just make a note of the points. Moving on to the next slide, that is saturable reactor method. Saturable, here the diagram is quite large. You can see similarly the primary winding and the secondary winding, primary with more number of turns and secondary with less number of turns, and the primary is connected to AC supply, and from that supply we have took, before the primary, from the supply, AC supply, we just took the connections to the bridge rectifier. You can see the bridge rectifier over here. Bridge rectifier made with diodes. Bridge rectifier made with diodes over here, and that is an input, and from the other two terminals the output is brought, one of the terminal to the rheostat and the other terminal to the reactor. The circuit is closed. And whereas the secondary of the transformer is as usually through the reactor to the electrode holder and to the electrode and the other to the workpiece. Just make the diagram neatly. Take a minute and complete the diagram. Okay, now we can see reactance can be adjusted by changing the value of DC excitation. And DC is obtained from bridge rectifier. Make the make a note of the 2 points. And control is through rheostat. Control is through rheostat. And if DC current is more, then magnetic saturation occurs and the reactance becomes less, and vice versa. If the DC current is less, the reactance becomes more. Make a note of the 2 points. Now coming to the characteristics of welding transformer. You can see in the x-axis you have current and in the y-axis you have voltage. And when the voltage is between 60 to 70, that is about 65, the current may be of 150, and it's of about 280, it's 450. So this is the characteristics of welding transformer. That means the voltage is fixed, the current can be changed by the above said methods: temperature changing method, movable coil method, the saturation method. Just make the diagram. Moving on to the next slide. The advantages of welding transformer. You can see a welding transformer, practical welding transformer over here. We have seen in the previous also. It's a low initial cost, work pieces do not get damaged, and low operating cost, less maintenance cost, and noise is also less as no moving parts, and overall efficiency is high. So these are some main advantages of welding transformer. Weight is low initial cost, and the workpieces do not get magnetized. The low operating cost, less maintenance cost since no moving parts, and noise is also less since there are no moving parts. Compared to welding generator, there are so many moving parts in it, and the noise is also more. Here we get only a just humming noise in it, and we all know the transformer has high efficiency than any other device, so it has overall efficiency is also high. Okay, then we'll see the disadvantages of welding transformer. Polarity cannot be changed. Polarity cannot be changed, and it has a very poor in power factor. And it has very poor in power factor. These are the main two disadvantages of the welding transformer, where the polarity cannot be changed and the power factor is very poor. Okay, there are some more pictures of welding transformer. You can just observe. Just observe. These are the practical welding transformers. Okay, so this is about the welding transformers. We'll just see a summary. Can you recollect what we have learned in the session? We have learned about welding transformer and the current changing methods like tapped reactor type welding transformer and moving coil type welding transformer and saturable reactor type welding transformer. This is in general we have learned a welding transformer, and there are current changing methods like tapped reactor method, moving coil method, and saturable reactor method. From these three methods we have three types of welding transformers. So these are the things which we have seen in the previous slides. So are you ready for a small quiz? Welding transformer should have dash characteristics. Just guess the answer. Welding transformer should have, I think it should have constant characteristics, and also in some point of view exponential characteristics, and also dropping characteristics. So I guess any of the above is right. Let us see what you will be guessing. Okay, we'll see how it's dropping characteristics. Sorry, the welding transfer should have dropping characteristics. Just read the question once again and just welding transfer should have dropping characteristics. Welding transformer works on the principle of Kirchhoff laws, Coulomb's law, superposition theorem, and electromagnetic induction. I think you can guess. You can guess the answer very easily. It's nothing but electromagnetic induction. See, you can see. And there are some frequently asked questions that explain with neat sketch working of taper reactor type welding transformer and explain with neat sketch working of moving coil type welding transformer and explain with neat sketch working of saturable reactor type welding transformer. So these are some frequently asked questions. So thank you one and all. That's it for the today's session.